The main advantage that we can store up to 10 of the modules in this carousel, how we call it, and yes, that's so we can just drive around the playground and collect up to 10 lunar modules, and then afterwards lay them down into the slots.
The big advantage is also that we have only 4 motors to handle everything. So one motor to rotate it, one motor to throw them out, one motor to collect the freestanding modules, and also it could be one motor to rotate them, but it wasn't also finished yet.
Yes. The electrics of this robot are so the main part of this robot are these boards. They are in this moment there are 3 equal boards, these 2 and 1 below this fan, and we just have different softwares on them. So one of the electronic boards acts as the master board and is the brain of the robot and calculates all the things to do and controls the motors. And these 2 are just for controlling more motors than one board can do. We used a lot of software from past seasons, but of course made some adjustments to fit the current season.
We also have fun action. It's a pretty nice 3D printed rocket.
This is our spaceship, and it is launched using a railgun mechanism. So it's just an electric coil down here, and there's a metal pin inside. And by loading some capacities and then closing a transistor, there's a large current flowing through this coil, and the metal pin is pulled upwards and just pushes out this rocket, which leaves the robot and yes, up to 50 centimeters maybe.
So as I said, we actually planned to build 2 robots, and the second robot is in the work now. But we also took him with us. So the main idea of the robot was to store the lunar modules here inside kind of lift, and then throw them out like this. And the really interesting thing about the robot is the drive. So usually Eurobot teams build a differential drive,
which means there are 2 robots and they're just driving the right and the left wheel, and by different speeds you can drive curves and circles and so on.
This year, to make the robot smaller, we decided to build such kind of drives. So we have 2 wheels in the front side with integrated magnet encoders, and then this kind of drivetrain in the back, so we can rotate it almost 360 degrees and then drive in any direction.
Okay.
So it's pretty compact. So we were able to build this big lift. Yeah.
And so, did you start making them at the same time, or did you decide to handle the modules on this one because this one didn't work?
Well, the idea was to
use them together.
Yeah, so the 2 could handle the modules together?
Yes,
Okay.
they have communication technology using radio, and so they can cooperate on the playground. But unfortunately it's not ready yet, and also the software needs to be written for this drive, and maybe next week for our German national competition.
Okay. And did you plan to use the balls at all? Or?
Well, yes. We already have a place in our robot for it. So you see there is some place here. The idea was to make some wheels here and some brush to collect them using a big pipe going inside. And as you can see now, the robot is already big and has almost no place for so many balls. So the idea was to make a tank which opens after the game starts to succeed the dynamic, to succeed the static circumference. So the idea will be if we push the starter pin, it will open, and then we'll be able to collect all the balls
and release them sideways out of this container.
But so far, we're starting to design the lunar model handling first, and it's didn't got ready yet, so we're still focused on it. But we're hoping that we will be able to participate in the European contest, and then maybe got the balls ready.